Hello. All right, this is question 6B of the 2013 A2 paper. All right. Prior to this program, I wrote one in which I wrote the file which is being referred to, just so that I could demonstrate how to write to a random access file, right? How to write a binary file. I will post the link to that video in the description of this one. All right, so let's proceed from there. So I just copied all the code which was written in the paper, and I pasted it here, right? And then let's look at what happens. And for reference sake, then I put this. I commented the array which contains the information which we copied to the file, right? Unfortunately, we can't read from the file because the file is written in binary and we can't read that format. It's all gibberish to us, so we'll be referencing from here, okay, because this is the same structure which was copied to the file. So we begin our main and we declare a variable, a student of type student struct, right? So meaning that a student has inside a field of a number which is an integer and another field letter which is a character. All right, so this is the structure. Okay, we open the file for reading and we do the normal procedure. We check if it could be opened. If it couldn't, then we stop. Otherwise, we start doing whatever we want to do. All right, so we now have rewind. What does this do? Rewind simply takes the cursor back to the beginning of the file. Right, so that is what that does. It takes the cursor back to the beginning of the file. So we're now at the beginning of the first structure, which is 0a. Okay, so let's look at that. Fread ampersand a student size of student struct 1 cfptr. Okay, let's look at what that simply means. So fread is a function that reads from the file, and the first argument we send to it is the address of the variable into which we are copying the information from the file, right? So where we're going to store this information that we're copying from the file, we need to send the address of that variable. And the second argument is the size of the information that we are copying, right? So the number of bytes that we're copying from the file. Okay, and in this case we're copying the number of bytes which is equivalent to the number of bytes occupied by the structure, and we're storing that information in the equivalent form, which is a structure as well of the same type. So this agrees together. Okay, now the third argument is the number of elements that we're copying, right? So if this was 2, then, and let's say that student struct is 10 bytes, then here I'm simply saying I want to copy only one 10-byte section. If this was 2, then I would be copying two 10-byte sections, meaning that I'll be copying 20 bytes. All right, so how many elements am I copying? And then the last argument is the pointer to the file, so that the function fread knows where it's taking the information from, where it's reading this information. All right, so let's proceed from there. So after this line, right, we would have read 0a, the first part, and our cursor now stands behind 1b. Okay, so we've read that, and then we print out. So I expect to see a0 being printed out, because here we started with %c, so we printed out the character first. So I expect to see a0, and then we read again, and remember from the previous fread our cursor was behind 1b, so now we are reading 1b and our cursor is now behind 2c. So we've read 1b and stored it in a student and overwritten the information which was stored previously in a student, which was a0. Now we've replaced it with b1, and then we can now print it out and we see that it should be b1. That is what I expect. Okay, what else? Now we notify users that we're going to use fseek with seek set, right? So let's look at what fseek does. So fseek enables you to navigate through your your random access file, right, or your binary file. So the first argument to it is the pointer to the file, so that it knows which file it's going to be performing its operations on. The second argument is the number of bytes you want to move, either ahead or backwards, right? And what determines direction is the argument which follows next, which is whence. So this second argument is the offset. Okay, it's called the offset. And the third argument is going to be whence. At least that is how it's described in the book, simply meaning where am I moving from which position do I start moving, and how do I move, right? So because this is a positive number, right, 1 times size of student struct, and previously I said that let's assume that it's 10 bytes for argument's sake, then it's going to move only 10 bytes, and now we need to tell it where is it moving from, right? Where does it start? 6 means go back to the beginning of the file, all right, and then start moving from there. So in this line, we've simply taken our cursor and put it at the beginning of the file using the commandment 6set, and then from there we move 12 bytes forward, 10 bytes forward, right, or the size of structure bytes forward. So we're now behind 1B, right? We're now behind 1B because we've moved past the first structure, because we moved here. The argument was to move the number of bytes equivalent to one structure, right? So we're now behind 1B, and then we read using that line. So our cursor is behind 1B, so now we've read 1B, and when we print it out, then I expect to see B1. Okay, we read again. So after reading the previous time, I mean, then we would have been now behind 2C. Then we read again, so now read 2C, and now we're behind 3D. So when we print out, we're going to print out 2C, C2, my apologies. Okay, and then now we use we tell the user that we're going to use fseek with seek current. Okay, so fseek the pointer to the file, and this time we're moving backwards, right? My apologies. Okay, this time we're moving backwards, right? The number of bytes equivalent to the size of the structure. So we were now behind 3D. Okay, we're now behind 3D, and the argument here is seek current, right? Meaning that we're moving from the position where we are. In the previous fseek, we took our cursor to the beginning and then moved 12 bytes forward according to the number of bytes specified in the arguments there. In this case, we are moving from where we are, seek current, right? Wherever we are, and we are moving from there. And the specification of the number of bytes is negative, the number of bytes of the structure, meaning that if we are behind 3D, then we move backwards one structure. So we're now behind 2C. Okay, after this line, we're behind 2C, and then we read using that. So now we are reading 2C again because fseek previously took us to 2C. So now this will print out C2. Okay, I put this in the wrong destination. Let me put it here. Okay, so we print out C2. We've read that. Now our cursor is behind 3D, and then we read again. So our cursor is now, we read 3D into the structure A student, and now our cursor is behind 4E. So now we read, and what we print out is going to be D3. All right. Then we notify the user that okay, now we are going to use fseek with seek end. All right. So all the other arguments are the same, except have the same meaning, except the last one, which is this one, seek end. Right. So what does seek end say? It means that we have to take our cursor to the end of the file after 4E, right? And then we start reading and we start positioning our cursor from there onwards, right? So we're at the end of the file in this case, and we are moving -3 times the size of the structures times the size of struct number of bytes backwards, right? So we are moving 3 structures backwards in this case. So we're moving through 4E, 3D, 2C. So we're now behind 2C. We've moved 3 structures backwards. Okay. Then when we read in this line, we're now reading from 2C. And then when we print out, then I should expect C2. And then we read again. So after reading, it took our cursor to behind 3D. Then when we read again, we're now going to read 3D. And when we print it out, it's going to print out D3. Alright, and we are done there. Now let's verify if this is actually what we will get, right? These predictions, and see if they are true. I'm going to run this. Okay, let me display them side by side. Alright, so the first one, A0, which is what we have there. Okay, the second one, B1, which is what we have there. We print out 6 set, and then we get B1, we get C2, we get another C2, D3, C2, D3. Okay, I hope this was helpful, and I hope that you saw how we analyzed the code, how we moved logically back and forwards, and I hope that you now understand the functionality of fseek and its arguments and the meanings imposed. Enjoy the rest of the day and enjoy your studies.